Hello everybody. What we're going to try to do in this video is write the standard form of an ellipse if you are given an equation that is not in standard form. And as a friendly reminder, we talked about the standard form of an ellipse looking like x minus h squared over a squared plus y minus k squared over b squared equals 1. So our goal here is to turn this equation into this standard form, which involves a little bit more complicated completing the square. Okay, so much like when I completed the square for circles, I am going to be looking at the x terms, and then I'm going to be looking at the y terms, and I'm going to attempt to make these perfect square trinomials. And right now I notice that this negative 39 is kind of in the way, so I'm just going to add it to both sides. And what I have now is 4x squared minus 24x plus 25y squared plus 50y equals 39. So let's start with the x terms. What's different about an ellipse is that we have a coefficient in front of the x squared. We have a 4. And I notice that 4 is also a number that goes into 24. So I'm going to factor this out. So if I take out the 4, what am I left with? I'm left with x squared minus 4 times what number equals 24? 6. And I have an x there. Now this is looking more like the perfect square trinomial that we've been working with circles. So I need to figure out what number to add here so that I can write this as x minus something squared. So I think most of you are pretty good at knowing what number to add here, and this number is going to be a 9. Remember, you take negative 6 and divide it by 2 to get your negative 3, and negative 3 times negative 3 is 9. Okay, so then I'm going to move on to the next part, my y values. Again, I have a coefficient in front of the y squared, so I'm going to start by factoring it out, and if I look at it, that 25 does have a common factor with 50. So I'm going to take out the 25, and I'm left with y squared plus 2y, because 25 times 2 is 50. So again, I'm going to be looking for a term that helps me complete the square so that I can write this as 25y plus something squared. Well, take the 2 and divide it in half. That gives me 1. 1 squared is 1. And that's how I complete the square. Now, here's something that gets a little trickier. Originally, this equation was equal to 39. Sorry, graph paper, running over. And I need to add what I added on the left side of the equal sign. But what's tricky is it looks like I added 9, but I actually added 4 times 9, which is 36. And over here it looks like I added 1, but really I added 25 times 1, which is 25. So that is how I balance my equation and make sure that it's equivalent to the original. And what I have here is 4x minus 3 squared plus 25 y plus 1 squared equals 100. One more thing until we make this a standard form of an ellipse. I know that the standard form of an ellipse involves fractions, and I also know that it always equals 1. So the reason we end up getting fractions with ellipses is because if I want to make this equation equal 1, I have to divide this by 100, which means I also have to divide the entire other side of my equal sign by 100. And remember, that also means I'm dividing each part by 100. So another way I could write that is divided by 100 divided by 100. So now I'm one step away from the final answer. I need to think about reducing 4 over 100. And that actually becomes, I'm going to move down here, x minus 3 squared over 25. Because you could think of 4 going into 4 one time, going into 125 times. And if I look at the next number, I need to reduce 25 over 100. 25 goes into 25 one time, it goes into 100 4 times. I end up with y plus 1 squared all over 4 equals 100 divided by 100 is 1. And that is the standard form of my ellipse. What can I get from here? I can get that the center is 3, negative 1. I can get the major axis value here. So the square root of 25 is 5. And I know my minor axis then is 10, because it's 5 plus 5. And I know that the square root of 4 is 2, which makes the length of my minor axis 2, plus 2, which is 4. Okay, so that's a whole lot of stuff. And we could practice sketching this ellipse, but what I want you to get from this video is how you can rewrite the equation of an ellipse into standard form. It involves some pretty complicated completing the square, but with some practice, you're going to be good at it. Okay, thanks. Bye-bye.